In this lesson, we're going to be talking about the basics of circles and tangent lines. You will be able to apply the properties of circles and tangent lines. First, we're going to start with some important vocab, the basic things that you need to know. Our first term is going to be diameter. A diameter is a segment or a chord that goes through the center of the circle. Our second vocab word is going to be a chord, which is a segment whose endpoints are actually on the circle. And our third vocab word is going to be a radius, which is a segment whose one endpoint is in the center and the second endpoint is on the circle. So continuing with vocab, our fourth term is going to be a tangent. A tangent is a line that intersects the circle at one point, in exactly one point. Where a tangent line intersects the circle is called the point of tangency. And our final vocab word is going to be a secant, which is a line that intersects a circle at 2 points. So instead of it being a line segment, this is actually a line that keeps on going forever, but it intersects the circle at 2 points. In our first example, I'm going to determine how to show you if a segment is in fact tangent to a circle. So determine if AB is a tangent line. Again, a tangent line touches the circle at exactly 1 point, and it also creates a right angle. So as you can see in our diagram, if it in fact creates a right angle, then that means we have a right triangle within our circle. So we're going to be able to use the converse of the Pythagorean theorem to check and see if AB is in fact a tangent line. A squared plus B squared equals C squared. We're going to plug in 18 for C because that's the longest side, and then 9 and 15 for the legs. 9 squared is 81, 15 squared is 225, 18 squared is 324. When you add 81 and 225, you get 306, which does not equal 324. So since they are not equal, we can say that it does not form a right angle. Therefore, segment AB is not tangent to the circle. In our second example, we're going to find the value of x using two tangent lines. Tangent segments from a common point are congruent or equal in measure. So both of these tangent lines start at point A. That means that they are congruent. So we're going to be able to set these expressions equal to each other. 3x plus 10 equals 7x minus 6. And then we're going to use inverse operations to solve for x. Minus 3x from both sides. That would be 10 equals 4x minus 6. Add 6 to both sides. That's going to give us 16 equals 4x. And finally divide both sides by 4, which is going to give us x is equal to 4. So that is how you use the properties of tangents to solve for variables and to determine if lines or segments are in fact tangent to a circle.